Hello, good morning everyone. So let's continue our discussion related to nested subqueries. In the last session, we had a discussion about one of the types of subqueries. So let us have a recap. SQL provides a mechanism for nesting the subqueries. So subquery is of the form select from where. So a query of the form select from where can be nested within another query. And the common use of subqueries is to perform certain kinds of tests. For example, the tests that can be performed are set membership, set comparisons, and determining the cardinalities. In the last session, we have seen set membership clauses. So we have seen the set membership clauses in and not in. And we have seen few examples how to make use of these clauses in and not in to check the membership of a particular tuple in another set provided by a relation. So today I'll be having few more examples for set membership, and then we'll proceed to the next category of examples or subqueries, and that is set comparisons. So let us look at one more example wherein we are using this in and not in clauses on enumerated sets. So what we mean by enumerated sets? These are actually the constant relations, you may say. Say for example, suppose we want to find out the names of instructors. We want to find out the names of instructors whose names are neither Mozart nor Einstein. So we want to list out the names of the instructors other than these two. Right? So if we want to write a query now using this set membership clause, how we are going to write this? Obviously, we need to make use of the instructor relation. So while writing the query, we are going to make use of a constant relation or the enumerated set of values. So the query that we are going to write is, see here, select distinct name from instructor where name not in Mozart, Einstein. So explicitly we are forming this set of values. Right? So this is our enumerated set. So wherein we are listing out the values. These values are comprising this particular set. And we want to extract the names of the instructors where name is not there in this particular set. Right? So instead of here having a relation R using some select statement or the subquery, simply we are making use of the enumerated set. And many times this kind of a construct with enumerated set is really very helpful. Right? So let's see now how we can implement it in Oracle. So let's first list out the names or all the attributes from instructor table. Right? So we are having actually the 12 instructors in this instructor table. And what we want is, we do not want to have the names like Mozart and Einstein. So other than these two, we want to extract all the names of the instructors. So we are going to write the query like distinct name from instructor where name not in, and now we are going to provide a set of values, right? So which names we do not want? We do not want Mozart and we do not want Einstein. Right? So if I try to execute this, so see here, right now we are having 12 records wherein we are having these two names, Mozart and Einstein, right? No name actually is duplicated. So ultimately, if I execute this query, what I'll be expecting is, other than these two, I should have all the instructor names. Okay. So if I execute this, I'll be having now 10 instructors, and in this set of instructors, we do not have this Mozart and Einstein. Right? If I provide the query like select distinct name from instructor where name in Mozart, Einstein, then what will happen? I'll be getting only these two. Right? So remaining 10 will not be extracted. Right? So let us try this one also, where name in. See here, I'll be having only those names. Correct? Those are present in the set. So instead of now distinct names, suppose I want to find out the name and salary of these two instructors. So what I can do is, I can write this statement like select distinct name, salary from instructor where name in this. So I'll omit this distinct also. So name and salary wherein the name of the instructor is Mozart or Einstein. Okay. So if I try to execute this, then what I'll be getting is, I'll be getting the salaries of these two instructors. Right? Those are included in this enumerated set. Okay. If I use here not in, then I'll be getting all other instructors along with this, their salaries, right, except these two. Right? So I hope you must have understood this form of the SQL construct, wherein we are using the enumerated set in the clause in or not in. Right? Now, let's proceed with the next example. So, suppose we want to find out the total number of students, distinct students, who have taken course sections taught by the instructor with ID 10101. Please see this statement carefully. What we want to extract the total number of students who have taken courses or course sections taught by the instructor with ID 10101. So how to write this query? Just think on. Please refer to our university database and please find out which tables or which relations we need to use. We want to find out the count, total number of students, right, who have taken course sections taught by the instructor with ID 10101. So, which relations need to be used? We are having teachers relation. And what information is stored in this teachers relation? In this teachers relation, we are having the information that which teacher or which instructor has taught which course sections in which semester and year. So all the information related to the courses taught by the instructors is stored in this teachers relation. And we are having another relation, text. So what we have stored in this text relation? In this text relation, we are having the information that which student has registered for which course sections in the respective semesters and years. Right? So the information about the courses taught by the instructors is available in teachers relation, and the courses or the course sections opted by the students, that information is available in text relation. So we need to make use of these two relations. So how we are going to write the query? We want to extract total number of students who have taken the course sections. Those are taught by a particular instructor. So whenever we are asked to extract total number of students, then we need to make use of the aggregate function. That is, which aggregate function to be used to find out total number of students? Yes?
Count.
Count, correct? So we need to make use of this count aggregate function. So see here, we are having these instances of text and teachers. So in our teachers relation, we are having this as the instructor ID, then course ID, section ID, semester and year. So this particular instructor has taught this particular course with section 1 in fall 2009. Once again, the same instructor ID 10101 has taught this course CS 315 section 1 in spring 2010 and so on. So this is the data available in our teachers relation. And what is there in text relation? Having the student ID and we are having the information like which course section, which semester and year is being opted by a particular student with this ID. So a student with ID 00128 has opted for CS 101 section 1 in fall 2009. 00128 has opted for CS 347 section 1 in fall 2009 and so on. So this is the information available in text relation. So we are going to make use of these two relations. And what we want is total number of students who have taken course sections. Those are taught by this particular instructor 10101. Correct? So we need to count the number of students. So the statement that we are going to write is, see here, select count distinct ID from text. So this ID is the student ID. Right? This ID is the student ID. So we are counting the student IDs from this text relation, where these attributes, course ID, combination of these attribute values, where course ID, section ID, semester, year, N. Select course ID, section ID, semester, year from teachers, where teachers.id is 10101. So this teachers.id is the instructor ID. And what we want to find the number of students who have opted for the course sections taught by this particular instructor with ID 10101. So this is my subquery. Right? This is my subquery. So what this subquery is giving me, what is this subquery is giving me? This subquery is giving me the course ID, section ID, semester, year taught by this particular teacher 10101. Right? And this is my outer query. What this outer query is giving me? This outer query is finding out the count of students, where this course ID, section ID, semester, year is member of this output of this relation, output of this subquery. Right? Are you getting me?
Yes, ma'am.
See here, once again, let us go back. See, now let us try to find out what actually is happening. So our inner query is giving us course ID, section ID, semester and year. These attributes we are extracting. Select course ID, section ID, semester, year from teachers, where teachers.id is equal to 10101. So we are having these three records having ID 10101. So the output of this inner query, is this. Okay, and what is the output of outer query? In outer query we are finding out select distinct ID. Count distinct ID, right, from text, right, where the condition we are supposed to match. Where what is the condition here? Once again we are matching these attributes, right? So where these four attributes, course ID, section ID, semester and year, right, in, then we are having the output of this inner query, wherein we are having these three tuples. So obviously what will happen? We are matching this course, these four attributes. So we are checking whether these four attributes are present in the result of this inner query. In the inner query we are having these three tuples. So we are matching, we are finding out the number of students who have opted for these three. So if we are having this combination available here, see for example, CS 101 1 fall 2009, that is available, right? Now CS 347, yes, so this combination is also part of this subquery. CS 101, this is also part of this inner query. Then CS 1902 spring, no, this is not the part of this. Okay, now CS 315 1 spring 2010, yes, this is the part of the inner query. CS 347 1 fall 2009, so this is also part of the inner query. So this is member of this inner query or the result of inner query, right? So this is how we are going to find out which tuples from the outer relation are members of the inner relation. So whichever are these combinations similar to one of these three, we are going to pick that tuple and that gets counted, right? So let us once again look at this query. Select count distinct ID from text where course ID, section ID, semester year in. Select course ID, section ID, semester year from teachers where teachers ID is 10101. Right? So we are computing the number of students who have opted for the courses. Those are taught by this particular teacher 10101. Right? So let us see now practically how it works. Okay? So let us try to write this statement. Select count distinct ID from text where course ID, section ID, semester year, then we are having the subquery. Select course ID, section ID, semester year, teachers where teachers.id is equal to 10101. Okay, now let me show you the partial results first and then we'll execute this query. So this is part of the query. Select course ID, section ID, semester year from teachers where teachers.id equal to 101. So these three are the courses. Those are taught by this particular teacher 10101. And what we are trying to do is we are trying to count the number of students from text relation where this particular combination belongs to. This combination is member of this relation. Right? So for whichever tuples from text relation we are having, either of these combinations will be picking up that tuple from text relation and that gets counted. Okay, so let's try to execute this entire query now. So we are having the count as 6, meaning 6 students have opted for the course sections. Those are taught by this particular instructor 10101. Are you getting me? Yes, we may rename this column as well, right? So here we may write number of students of this count. So number of students who have opted for the course taught by instructor with ID 10101 is equal to 6. Are you getting me?
Yes, ma'am.
May I proceed?
Yes,
Yes, ma'am.
ma'am.
Yes? Fine. So now let's go to the next type of queries. Those we are going to understand under the subqueries. So we can have the set comparison clauses as the subqueries. We'll see one example first and then I'll try to explain you how actually this construct works. So let us try to write the query. Find the names of all instructors whose salary is greater than at least one instructor in the biology department. We have written this query earlier, right? So whenever we discussed about tuple variables, if you remember, tuple variables, meaning renaming the relations in SQL statements. So whenever we discuss tuple variables, we have written this query. Find the names of all instructors whose salary is greater than at least one instructor in the biology department. So to write this query, we used instructor relation twice. And we renamed those instances of instructor relation. And by using the appropriate conditions or predicates in where clause, we were able to get the result. So earlier we have written this query like this. Select distinct T dot name from instructor as T, instructor as S, where T dot salary is greater than S dot salary and S dot department name is equal to biology. So with this construct, it is possible for us to find out the names of instructors whose salary is greater than at least one instructor in the biology department. Right? So we have seen this query earlier. Now, to make it more simple, we are having this set comparison clause and that is sum. Right? So, phrase greater than at least one, greater than at least one can be represented in SQL by the construct like greater than sum. So at least one means sum. At least one is equivalent to this keyword sum. Right? So if we want to find out greater than at least one, then in SQL having a construct that we may use greater than sum, greater than some tuple, greater than some value, right? So how we are going to write this query? See here, we are writing this query alternatively like select name from instructor where salary is greater than sum. And then this is my subquery. So what is this subquery? select salary from instructor where department name equal to biology. So what this statement will provide me, select salary from instructor where department name equal to biology. So this inner subquery will provide me the set of salaries. This will provide me one column, salary, wherein I'll be having all the salary values from the department name biology. So if I am having say 4 instructors from biology department, then I'll be having the salaries of these instructors from biology department, right? So this is what this inner query is providing me. And what I'm writing that I want to extract the name of the instructor from instructor table where salary is greater than sum of these values. What does this mean? Suppose, say for example, in the outer query, I am having 12 instructors. I am having overall 12 instructors, right? So in the outer query, for these 12 instructors, I am having some salary value associated. So in this nested subquery, what will happen is, from outer query, every salary value is being tested, is being compared with the salary values those are obtained as a result of this inner query, right? So in the outer query, suppose the instructor 1 is having the salary say 65,000. Then instructor 2 is having, suppose the salary say 70,000, and so on, right? And in the inner query, suppose I am having say 4 instructors, those belong to biology department, and the salary of those instructors is say 30,000, 50,000, right? Then 40,000 and say 80,000. Let us assume. Okay, so what will happen? From the outer query, every tuple is being picked up and the salary gets compared. So for the first tuple, say salary is 65,000. So this 65,000 salary is compared with these salaries, right? So we are checking whether this salary is greater than sum. Sum means at least 1, right? So whether 65,000 is greater than at least 1 out of these 4. At least 1 out of these 4, 65,000 is greater than 30,000, yes, greater than 50,000, greater than 40,000 and less than 80,000. So 65,000 greater than at least 1, greater than these 3. That means greater than sum is being evaluated as true, right? And this is how the name of this instructor will be included in my final result, right? Are you getting me?
Yes, ma'am.
Let me give you one simple example so that you can understand the concept. See, definition of sum clause. So these are few examples. So we are comparing one value from the outer query with the values those are obtained via the inner query. So this is actually the relation R, wherein I am having extracted few of the values. Let us assume. Okay. Now, what we are using here is, we are using 5 less than sum, and the inner query has provided us this set of values. So whether 5 is less than some value that is present in this relation? Yes or no? We are reading this like 5 is less than some tuple in this relation. So whether 5 is less than some means at least 1. So whether 5 is less than at least 1 tuple out of these?
Yes.
Yes.
Yes, ma'am.
5 is less than this 6. So 5 is less than at least 1 tuple out of this relation, right? So this entire thing will be evaluated as true. And if it is evaluated as true, then that particular tuple in the outer subquery will be extracted in the result. Okay, because this condition is evaluated as true. Now, let us see one more. Whether 5 is less than sum of this relation, some tuple in this relation. So, in this relation, we are having 2 tuples, 0 and 5. So, whether 5 is less than sum of these tuples?
No.
No. Because 5 is greater than 0 and 5 is equal to 5. So 5 is not less than any of these tuples, right? So this will be evaluated as false. And if this is evaluated as false, then that particular tuple in the outer query will not be included in our final result. So whenever this condition with this construct sum gets evaluated as true, then that particular record is extracted in our final result. Otherwise, no. Okay. Now, see here one more example. 5 equal to sum of these tuples. 5 equal to sum of these tuples. Sum. S-O-M-E sum. So, this will be evaluated as whether 5 is equal to at least 1 out of this.
Yes.
Yes, we are having one tuple, 5 equal to 5, right? So, this will be evaluated as true. And if this is evaluated as true, then that tuple in the outer query gets extracted in the final result. One more, whether 5 is not equal to sum of this. So sum means at least 1. So 5 is not equal to 0. 5 is not equal to 0. So we are having at least one tuple that is not equal to 5. And that is why once again it will be evaluated as true. And the respective tuple from the outer query will be extracted in the final result. Got it? So I hope you must have understood this. So let's try to implement this. So let us try to write the query. Select name from instructor where salary is greater than sum, and this is our inner query. So what is our inner query? Select salary from instructor where department name equal to biology. Right? Now, see here, I'll be partially showing you the results. So if I try to execute this query, select salary from instructor where department name equal to biology. then I'll be getting the salaries of the instructors from biology department. So we are having only one instructor from biology department and the salary is 72,000. Right? So what we are going to do is, let us execute this statement and look at all the salary values. So we are having 12 instructors with the respective salary values. So what will happen? Every salary value is being compared. Every salary value is being compared with the salary value of this inner query. In this inner query, we are having only one salary value. So that gets compared with this inner salary value, right? So right now we are having only one salary value, that is 72,000 from biology department. So every salary value gets compared with this 72,000, right? So greater than sum is evaluated as greater than at least 1. So if the salary value is greater than this 72,000, then that particular name of the instructor will be included in our final result. So let's try this. See here. So these are the instructors. So let us try to list out the salary so that we can understand. So see here, these are the instructors with the respective salaries, and these salaries are greater than the salary of the instructor from biology department, that is 72,000. Right? So this is how we can make use of this greater than sum clause. Is that clear? Yes?
Yes, ma'am.
Fine. Now, let's proceed with another clause under set comparison, and that is all clause. So all clause. So see here, I'll be giving you the definition and we'll see the example for this all clause. It is once again similar to that of sum. So we have seen sum. So sum means at least 1. And all means we should satisfy the condition for all the tuples, for all the values in the inner query. Say for example, we are having here 5, we are comparing less than all, and the inner query is giving me these 3 values. So 5 gets compared with all those values. So if 5 is less than all these values, then only it will be evaluated as true. Otherwise, it will be evaluated as false. So 5 is less than 0, no. Right? So obviously, this will be evaluated as false. Right? And if it is evaluated as false, then this respective tuple in the outer query will not be included in the result. Okay? Now, if we see this 5 less than all, and the inner query is providing us the relation with these 2 values 6 and 10. So whether 5 is less than 6? Yes. Whether 5 is less than 10? Yes. So 5 is less than all the values. Those are included in this relation. Right? And that is why it is evaluated as true. And if it is evaluated as true, then that particular tuple in the outer query will be included in the result. Now, see here, 5 equal to all, 4, 5. So, whether 5 is equal to 4? No. Right? So, this is not true. And that is why the entire result is. So, if 5 is equal to all in all the values in this relation is not satisfied, then the output is false. And if it is evaluated as false, then the outer tuple from outer query will not be included in the result. Right? Now, see this 5 not equal to all 4, 6. So this will be evaluated as true because 5 is not equal to 4, 5 is not equal to 6. Right? So all the values are satisfying this condition. So this will be evaluated as true. So if it is evaluated as true, then obviously this tuple from outer query gets included in my result. Okay. So let's see one example. Find the names of all instructors that have a salary value greater than that of each instructor in the biology department. Each instructor. Each instructor means all. We need to check all the tuples from biology department. So find the names of all instructors that have a salary value greater than that of each instructor in the biology department. So here we need to make use of this all clause. So how we are going to write the statement? Select name from instructor where salary is greater than all. And this is the inner query. So this inner query is giving me the salary values of the instructors from biology department. Right? And I am comparing the salary of every instructor with the set of salary values provided by this inner query. And if the outer salary value is greater than all those present in this inner query result, then only that instructor name will be included in my final result. Right? So this construct that is greater than all is equivalent to greater than all is equivalent to greater than all or each instructor. Have you understood this concept? Yes,
ma'am.
fine. So simply let's see how we are going to implement this. Select name comma salary from instructor where salary is greater than all. Select salary from instructor where department equal to biology. Right? So instead of some means at least one and all means each of this inner query. Okay? So we are getting this result. So as we are having only one instructor from biology department, let us try to change the name of the department so that we can understand whatever we are trying to do. So let us see here. Any other department wherein we are having more than one instructors. So we are having physics department, we are having 2. Okay, so let's try to replace this with physics and let us see what will happen. We do not have any record. And what is the reason? This is our inner query. Select salary from instructor where department name equal to physics. So 95,000 and 87,000. These are 2 salaries. And what we want is, we want to extract now the names of the instructors such that salary of the instructor is greater than all of this. So obviously all means if the salary is greater than 95,000, then only we'll be getting that in the result, get that instructor in the result, right? So let us see now these salaries. So see here, 95,000 is actually the highest salary that we have, and no other instructor is having the salary which is greater than 95,000, and that is why we are not getting any instructor in the result of this query. Right? Now let us change it as computer science department. We are having 3 instructors in computer science. So let us see what happens. Once again, we do not have any record. Right? So if we try to execute see here, we are having 92,000, 75,000, and this is null value, right? So the salary of every instructor is being compared with all of this. Let us try to replace this first. Let us try to remove this null. So update instructor salary equal to 65,000, where ID equal to 10101. Okay. Now let us list out the salaries of computer science people. So if now we execute this statement, what will happen? Select name comma salary from instructor where salary is greater than all. So the instructor having the salary greater than all of this means greater than 92,000, that should be extracted. So we are having only one person who is having salary that is greater than 92,000, which is the highest of this, right? So Einstein would be the result. Got it? Any doubts so far? Yes? Any doubt?
No, ma'am.
Fine. I hope you must have understood these constructs, all and some. Those come under this set comparison clause, right? In the next class, we'll see few more examples of this set comparison clause, and then we'll proceed with the next construct, right? Exist and non-exist, right? To find out the cardinality, to find out the empty relations. Okay? So let's stop today. Thank you.